our learners the best possible way we can, and this is only through us working as a collective. This is session number 3. Remember, we have now session number 1 and 2 as recorded videos on our YouTube channel. Just search for Nambane Academy, you'll find that, and you'll be able now to to revise accordingly. Ladies and gentlemen, I will not waste any time. We have our presenter, Mrs. Via Bezedin-Hout. She'll be taking us through electrostatics, focusing on capacitance, and the session might just not take an hour, only because of the nature of the topic we are doing. So maybe you can push for 45 minutes or so. Feel free also to ask questions if you have any, and then that will be discussed further. With that being said, maybe in Hout, we have people who have joined using the YouTube channel, and others will be joining using Microsoft Teams. That is how we are flexible in terms of all this. So with that being said, maybe Hout, all the best and good luck.
Thank you so much, Mr. Nambane. Today we'll be focusing on electrostatics in grade 12 technical science, that is capacitance and capacitors. If we start with our examination guideline, we will see that there are a couple of definitions that can be asked. So the examiner can either ask you the definition of capacitor, which we already know is very easy, a device for storing electrical charge. And this word electrical charge must be used. You cannot say any other word. I don't even want to use those words. I want to use the correct word for storing electrical charge. The second definition that they can ask you is capacitance. So they can also ask you capacitance because sometimes an examiner is like, everyone knows capacitor. Do they know capacitance? But they have to calculate it. So capacitance is the amount of charge it can store per volt. And we will look at these when we deal with the formulas, because the definition is also the formula. The second thing that we need to know in this topic are what are the uses. So these are examples of capacitors in technology, as well as we need to discuss the factors that are affecting capacitance. So these are the different topics that we are going to deal with in this topic. So let us get started. Sorry. So in our examination, we are going to get a formula sheet. Here are the formulas that can be asked. Yes, there's also this one that can come up in a couple of question papers, which you can see if you're going to Nambane Academy to look for some of the question papers, you'll find it in, I think it's the Limpopo question paper of last year, where they have this formula as an example. But nonetheless, let's get started. If we look at formula number 1, and we call this formula number 2. In formula number 1, we can see that we have capacitance is equal to charge divided by voltage. Now, why did I write it out? I wrote it out because some students confuse Q and charge, because charge is Q, but what is the SI unit of it? It is in coulomb. So don't make that mistake where you are calculating charge or something and then you are using this as your SI unit. So if we recall now the definition of capacitor, capacitance is the amount of charge it can store per unit volt. So what is that? It is charge divided by voltage. And on the examination guideline, they are saying you must be able to relate SI units for capacitance. So the unit of capacitance is capital F, standing for farad. And the examination guideline wants you to relate the fact that 1 farad is equal to 1 coulomb. From maths. This becomes negative when you put it up. So this is one concept that comes up a lot in multiple choice questions. The second formula that there is the one that is using area. So mostly I like my students to use this one because K is equal to 1. So I like my students to use this one because if you have K, sometimes you're stuck thinking there's no K given in the question. So this is equal to the permittivity of free space multiplied by area divided by the distance between the two plates. These are now the formulas that we are going to use. Now let's go in further because this is not a new topic to you. We are revising. Here are capacitors, 1, 2, 3, 4 capacitors, 2021 question paper. If we look at capacitor number 1, I'm not sure whose mic that is now. Okay, somebody's mic is making a noise and I'm not inside of Teams. But thank you, I think it's gone now. If we look at capacitor number 1, capacitor number 2, capacitor number 3, and capacitor number 4. You'll all agree with me that capacitor number 1 is a square or rectangular object. Capacitor 2 is circular, capacitor 3 circular, and capacitor 4 is circular. So if you had to calculate the area, because area is involved here, and when we're revising it for capacitance, we're also revising it for other topics where we use area as well, which is Pascal's law in hydraulics. And we also use area in stress, which is elasticity. So it will be the same. If we had to calculate the area first of this capacitor, we will use length times breadth. Why? Because it is a square object. Rectangle, it would be the same. Then for these three, what would we use? We would use pi r squared. Now remember very well, when we deal with area, there are definitely conversions that need to take place. And I want to recap those. So what conversions are there? Let's start with the conversions in length, because they can give you the side here and the side there. That is length. Or they can give you the diameter or the radius. That is also a length. So length, they can either give you millimeters or they can give you centimeters. And you need to convert that because the SI unit for length is meters. What will we do? We're going to multiply here by 10 to the power minus 3. And here we're going to multiply by 10 to the power minus 2. That is conversions of length. But we also have conversions of area, because the examiner can ask you in a different unit, knowing that you know how to convert. So the same with this. Area's SI unit is meter squared, but the examiner can give you millimeter squared and the examiner can give you centimeter squared. Then you have to convert to the correct unit, which is meter squared. How are you going to do that? You are going to double everything here. So it's going to be multiplied by 10 to the power minus 6, and it's going to be 10 to the power minus 4. This is before you can even use a formula. You must take note of possible conversions. Besides conversions of area, we also know that there is a conversion for diameter to radius. What do we do? It's in many topics. We divide the diameter by 2 in order to get the radius. And remember, the diameter can be given in one of these units. You must convert and then divide it by 2. What else is involved in capacitance? We also have a concept of charge. So when it comes to conversions of charge, there can be multiple conversions of charge, but those are from grade 10. The first topic in grade 10, you had these conversions. So there's nanocoulomb, there's microcoulomb, they can even be picocoulomb. doesn't matter. The fact is charge is measured in coulombs, so you need to convert before using the formula. Nano is 10 to the power negative 9, micro 10 to the power negative 6, and pico 10 to the power negative 12. So you must make sure in the topic of capacitance, topic of stress, topic of hydraulics, you have the correct units for area. And then for charge, it is now here in this topic. What else do we have? We also have voltage in this topic. So, and we are revising this also for electric circuits if they are coming on Friday because it's a topic in the exam. So voltage also, they can give you millivolts. Milli is the same, mm. So you have to also convert this to volts, which will be 10 to the power minus 3. Please, I would even write it here. Please make sure you check for conversions before substituting, because this is a big problem. Substituting. Please, it's a favor that I'm asking. Once you can do all these conversions, a formula is simply something of plug and play. Let's move on. Here we have now a capacitor. It's labeled here. This is my circuit diagram. It's labeled here. This is the symbol of a capacitor. These are the two plates that we are talking about because we are saying that capacitance is the amount of charge it can store. What is it? It is the capacitor itself. Now, the capacitor is made up of two separate plates which have a dielectric in the middle. When I go to the next slide, I will show you. But you can see it here for yourself. There is one plate on this side and one plate on the other side. Now, how do we know whether a capacitor is charging or discharging? Here are the graphs for it. When it is charging, what are we saying? We are saying that voltage is increasing over time. Because if you take, for example, your cell phone, you connect its battery low, you have to connect it to a charger. Over time, your battery becomes full. Discharging, on the other hand, we are saying that the voltage is decreasing over time. Because here, what are the variables involved? The variables are voltage is your dependent variable and time is your independent variable. So how do you know if a capacitor is charging or discharging if you are not given a graph? You will see it from a circuit. If the circuit is a closed circuit, like for here, you can add a switch. If the switch is closed, then what is going to happen? It is going to discharge. Why is it going to discharge? It's going to discharge because the capacitor itself is a device for storing electrical charge. And these charges are needed. For example, let's say the capacitor is a power bank. The moment you connect your phone, closing the switch, connecting the phone to that capacitor, what happens? The battery of the power bank loses voltage while that phone gains the voltage. So the capacitor is going to discharge when the switch is closed. When it is open, it is simply going to remain the same. Okay, it is simply going to remain the same. So we are going to look at a closed switch for this concept of discharging. The capacitor is going to discharge. What does that mean? It is going to lose voltage, or the voltage is going to decrease. When it is charging, because you can't charge your power bank, then it's going to increase the voltage over time. So I was just thinking, if a graph maybe had to come, it could be one of these. It could be a multiple choice. It could even be for your scientific method question or just a general question. Right, so now let's look at the factors that affect capacitance. Here's a capacitor. These are now those two plates. One side is positive, one side is negative, one side is positive. And then in the middle here, you've got your electric field. This blue part here is a dielectric material. Now, there can be different kinds of dielectric materials, and that will also determine how much capacitance there is, which we'll look at in a moment. This blue area here is the distance between the two plates, which we can use in the specific formula. This formula, permittivity of free space, area divided by distance. So in this formula itself, you've got variables that can affect resistance. The area can affect resistance, as well as the distance between the two plates. So because these are variables playing a role, distance between the two plates. They are playing a role, and we can even solve that by calculation. And then another factor, another physical quantity that's playing a role in capacitance is going to be the area itself. So this distance, how close are the plates and how far the plates are from each other, is going to determine how much capacitance there can be. The other thing that will affect it is the distance between the two plates. And then the last thing that's going to affect it is the type of dielectric material. So these are the three concepts that are going to affect capacitance. Okay. So you can see here you've got upper conductive plate, lower conductive plate. Here's your electric field. It's going from positive to negative. The distance, it will depend on the question. And then obviously the area is this part here. The larger the area, what will happen? The smaller the area of the capacitance, what will happen? All right. So let's check now. What are we saying? We're saying that the plate area, if the plate area is larger, there will be more capacitance. For example, using this formula of ours, if we say the distance for the two plates is 1 centimeter, and then we have another capacitance where the distance between the plate is also 1 centimeter. Then now the area of this first capacitor, this is capacitor 1 and capacitor 2. This area is now, let us say, 5 centimeter cubed, and this one is 15 centimeter cubed. This is the plate area that we're talking about. If you put this into your calculator, you can solve it even. You can say that this is for capacitor 1, and this formula is going to be for capacitor 2. So in other words, what am I saying? I'm saying that the permittivity of free space multiplied by the area, which is going to be 5 centimeter times 10 to the power negative 4, divided by this distance, which is going to be 1 times 10 to the power negative 2. If you calculate it for number 1 and you calculate it for number 2, you will see that there is a difference in the answer. What is that difference? Is it increasing? 15? Oh, there's not enough space here. Okay, let me just write it on the space that's available now, because I'm trying to fit it into a space where it's not fitting. Right. So that will be for number 1. And then for number 2, I will do it on this side, while you are using your calculator. This is for number 2. So permittivity of free space. (8.85 times 10 to the power negative 12). 15 times 10 to the power area negative 4 divided by 1. Both of them have the same distance. Now, what answer did you indeed get? Let's calculate it. 2 seconds. All right, you should be done now with your calculation. So here for capacitor number 1, what did you get? You got 4,425 times 10 to the power negative 13 SI unit farad. Then now for your capacitor 2, it was now 50, not 5. So you got here 1,328 times 10 to the power negative 12 farad. Now here the issue is you're not used to working with these small numbers, so it's difficult for you to see. But this is in scientific notation. 12 is a smaller number. Negative 12 is a smaller number. That means this number is larger. And this number is smaller. So what happens now when it comes to the area? The greater the area, the more the capacitance. The less the area, the less the capacitance. So they are what? Directly proportional. Directly proportional. Now let's look at the distance one now. That is going to be now our second example is going to be the one now of the distance. When we compare the distance as well, if the distance changes, what is going to happen? Here, my notes are telling you that if there is a bigger space between the plates, there is less capacitance. If there is a smaller space, that space is having the dielectric, there's going to be more capacitance. Why? It's still from the formula. If you have a larger distance, you are dividing by a larger number, which will give you a smaller capacitance. If you have a small space between them, you will divide by a small number, which is going to give you more capacitance. So these are how you, if you are not someone that likes to cram, then understanding is the best way to go. The dielectric material, it depends on the type of material it's made out of. If it is air, it is 1. But if it is glass, it is 7. So that dielectric material will determine. So this one has more capacitance because its permittivity constant is greater than air. So, and there can be other examples like mica, for example, is also used in capacitors in most devices. So it depends on what kind of dielectric do you have and how will that affect your capacitance, right? So these are the concepts now that we have dealt with. We have dealt with the formula itself. We have dealt with the factors affecting capacitance. We have dealt with what is a capacitor. We have even dealt with charging and discharging because I've seen it before. And now, what are we going to do? The calculations. So let's start. The first calculation that we have is the Free State paper of 2022. That is last year. I'm sure by now, because you're studying, you've already looked at the paper, but maybe you haven't got this far. So question 8, yeah, around about there is capacitance, this topic of electrostatics. So let's start. A fully charged capacitor with 2 parallel plates has a vacuum as a dielectric material. The plates are 4,26 millimeters apart, and each has an area of 13,5 watt centimeters squared. What did I write? I said, please do what? Please check for any conversions before attempting any question. So already here, I know that I have to convert to meter squared. And already here, I know that there's no way I'm going to calculate without converting to meter. How do we do it? Milli times 10 to the power negative 3 Centimeter to meter is times 10 to the power -2, but when it's squared, we double up. So we are going to do times 10 to the power -4. Regardless of what the question is saying, start with conversions. Define the term capacitance for 2 marks, a device for storing electrical charge. This word is even there in the moderator's report. Charge. Do not use any other word. 0.85 times 10 to the power -12, sorted. On the formula sheet. Take it out before you start your exam. Then the area is given 13,5 times 10 to the power -4. Then the distance between the plates are given 4,26 times 10 to the power -3. You put it into your calculator, you get your final answer, which is going to be what? 30 seconds to use your calculator. Do not always try to attempt to convert before starting the question, because sometimes what happens is you write it incorrectly from the previous place that you are using. Sometimes you use a corner, or I don't know what you do, but just be comfortable with putting everything, substituting everything into your calculator as it is. And if you have done that, then you will get 2,8. It's 0.5. So 805, 3 decimal places. The exam rule number 10 says what? A minimum of 2 decimal places. So another person would have 8,1 times 10 to the power -12 farad. So it's very easy. Just attending this class, you know that you're going to definitely get this definition, a device for storing electrical charge. You know that you're going to get this calculation. Now, here's one that your other friends who are not attending this class will not know. How will the capacitor be affected when the switch is closed? When the switch is closed, what is going to happen? The capacitor will discharge. So over time, it is going to lose the volts that it has. Voltage will drop. And you know, our examiners, you saw from maths paper 2, that they really, really want us to think in these trial exams. So let us be prepared, really, really prepared. So that is Free State 2022 question paper. You are done. You are done. This is your mark. These 6 marks, they are yours. 6 marks are yours. Let's move on. 8.1. A capacitor is made up of 2 plates separated by a dielectric, which is an insulating material. Capacitors are used in most electronic devices, radios, etc. Complete the sentence below. The SI unit for capacitance is 1 farad. 1 farad equals to, there we go. It's this formula. The SI unit here is coulomb, voltage. So it is equal to C to the -1. I think it will be a multiple choice question. We will see on Friday. Name 2 factors that influence capacitance. Here, I want you to be very, very specific. I really want you to be very specific. Area of what? Not just area. Area of the plate. Those are your marks. What else? Not just distance. Distance between the plates. We must be technical because we are doing technical science. And what else? The type of dielectric. because as I showed you there, if it is air, it's 1, but if it is glass, it's 7, and there are many other dielectrics given to us. Okay. Now let's try this one. It's the last question for me, or from past papers. Again, define the term capacitor. Remember now, as much as we over and over saying a device that stores electrical charge, watch out for capacitance as well. Watch out for it. So 8.1 is our beloved definition, and that is a capacitor is a device for storing electrical charge. Charge. 2 marks are yours. No matter what happens in other questions, these 2 marks are yours. Now, 8.2. Calculate the voltage. Voltage is which formula? It's got to do with this formula, yeah. It's 6 marks. We'll check now what do we have to do. Calculate the voltage of a battery connected to a parallel plate capacitor with an area of 2 times 10 to the power negative 4 meters squared. Correct unit. The plate separation. They can use any words. Separation, it's still fine. 2 times 10 to the power negative 3 meters. Correct unit. If the charge stored on the plates is charge, Q. I don't know why people are confusing C and C here of capacitance. Charge is Q. It is 4 picocoulomb. Pico, you must convert. 4 times 10 to the power negative 12 coulomb. Capacitance is C, but charge is coulomb. Do not confuse them. Now, what are we doing? We are going to substitute using our formula. What is given to us? Capacitance, is it given? No. Voltage, is it given? No, we have to calculate it. Charge is given. So what do we have to do before? It's 6 marks. What do we have to do before this? We have to determine the capacitance. How will we determine the capacitance? We have to use both formulas this time. Because I said to you, first check the variables. The final formula, we are going to use this one, but we need capacitance before we start. So don't feel like just because the variable is not given, you are stuck. No, if it's 6 marks, think like there's something else that I need to do. So the first step, we are going to use the first formula. So this is going to be C is equal to the permittivity constant, and it's in a vacuum. Oh no, they didn't actually say it. That was the previous question. So it's going to still be the same permittivity constant that we're used to. So let's start. C is equal to permittivity constant times area divided by distance. That will be 8,85 times 10 to the power negative 12. Our area was given to us 2 times 10 to the power negative 4. And then divided by the plates, it's in the correct unit, which is 2 times 10 to the power negative 3. Let's put that into our calculator. Some people don't have a good relationship with their calculator. I don't know why. You must not be afraid to use scientific function. So now you are busy calculating it. And how much did you get? 8,85 times 10 to the power negative 13 farad. Now you've got capacitance and you've got charge. Now you can calculate the voltage. So let me write it here for you. So now we've got this capacitance, so we're going to use it in our final formula, which is going to be 8,85 times 10 to the power negative 13. Then we've got 4 times 10 to the power negative 12 divided by V. Cross multiplication. V is going to be equal to what? Are you done with your computation? There you will get volts. So always use your question marks, the marks allocated as a guide. Here, what did we have to do first? We first had to calculate, this was step number 1, step 1. And then the answer here, we were able to use it in step 2. And that is basically now capacitance. What can they give you? Anything. You must be ready for all of those topics that appear in our examination guideline. And these are picture credits, and we thank you so much for watching.
Thank you very much, Mavia. Nicely explained, and I believe our learners and the teachers that are here actually benefited. Like I said, this is not a very long session or a topic on itself, but thank you very much for explaining it in detail. And I believe our learners will be able now to get the desired marks and prepare now for the trial examination as well as the final examination. Ladies and gentlemen, from my side also, thank you very much. Be on the lookout. We are also going to have a session like this for our chemistry that will be now the paper 2. Remember, paper 1 is 150 and then paper 2 is around 75 marks or so. But now the history has taught us that paper 2 is actually where majority of our learners are losing marks. So be on the lookout also. I believe the link will still be the same. If you do not have the link, do not panic, and you will be able now to get the videos on our YouTube channel. Ladies and gentlemen, I'm not going to say if you have questions or any inputs. You can feel free to do so, but I don't see any hands, I don't see any comments in the chat. That is basically that President Holt did an exceptional work. Ladies and gentlemen, from me to you, all the best for your examinations on Friday. And those that are not writing on Friday, because I can see a few people from KZN that are going to write on the 22nd, also the best. Remember, the videos are available for you to uh, go and watch now this session. Kindly subscribe and tell a friend about us. We are only trying now to support every child that is now doing technical science in 2023. With that being said, ladies and gentlemen, thank you very much and have a lovely day.